So the project that I'm going to showcase today involves 3D printing, it involves rapid prototyping, it involves three-dimensional laser scanning, and it involves a lot of the technologies that we're talking about through the course and is a good case study to put forward. This is the Natural Bridge Battlefield Historic State Park Eagle Monument that has had vandalism and has suffered from exposure to weather and elements from its erection in the 1920s to the present day. And so the University of South Florida has partnered with the Florida Park Service and with the Florida Bureau of Archaeological Research to protect, preserve, and conserve this monument going forward into the future. The monument is an eagle on top of a granite structure that actually commemorates the Civil War in Florida. This was a Civil War battle, the second largest in the state of Florida, where the Confederate Army actually held off the Union. So this monument is actually commemorative of that battle. It's a 6-foot wingspan copper eagle that sits atop this monument, and the eagle is really what has been vandalized. So the state is trying to conserve it and to figure out a way to make a replica or duplicate it, to have a replica on display at the park to replace the damaged eagle. So we brought 3D technologies to this project as an answer, a possible solution. And what we did was we worked with the conservators who were looking at this damaged piece and trying to figure out ways in which they could stabilize the piece and have it digitally preserved. And for that, we utilized three-dimensional laser scanning. 3D scanning can be done at a variety of ranges and scales. In this particular instance, we utilized an articulating arm that collects data at a really high rate of accuracy and precision, and we were able to 3D model the entire eagle as it is. So it contained, our 3D model captured all of those bullet holes and all of the damage that has been done to this copper piece. And from that, we create a record, a digital record of this monument. Then we can bring that digital data into different types of software. We can actually re-sculpt and repair in a digital life that sculpture. And so what we did was we actually repaired a lot of the holes. We actually re-sculpted some of the feathers. So we actually end up with a three-dimensional model that is a repaired version of the vandalized model. And so we talked with the Park Service and have worked with the Bureau of Archaeological Research to actually come up with a strategy to create a replica from our 3D data. And so what we are doing first is manipulating this data in 3D, getting it all fixed and watertight, ready to go to a 3D printer to create a prototype, to make sure that this is what we want things to look like. Those smaller scale models help us understand how good our model is, what it's going to look like as a final product. It's a real prototype way that we can share a tangible result with the public, with the other people that we are working with on this project. So our 3D print becomes a piece in and of itself. It's a part of the story. Once we have the 3D print, we can also do a subtractive type of technology through CNC milling. And milling is going to allow us to actually create a model out of something like foam or a more rugged material that we actually take away material from a block, and using the digital data, we can recreate exactly what that piece looked like. So it all starts with 3D scanning, then it goes through the computing and the modeling side of it after the reality capture side. Then from the modeling side, it actually goes to a replica development side using 3D printing. And then from the prototype, it goes right into the milling process. From the milling process, we can actually create a model that can be used to create a cast of this. And we can work with a foundry. In this case, we've decided that for the long-term stabilization and conservation of this resource, we're going to choose bronze as a medium. And we are going to actually recreate a full-scale 6-foot wingspan eagle made of bronze from our original reality capture of that object. So one of the great things about reality capture and 3D printing and these kinds of 3D technologies is there's so many things that come out of the very same reality capture and model process. Not only are we protecting and preserving our heritage and our potentially our world heritage at other sites and other monuments around the world, these same workflows can be utilized, but we're also able to bring that back to the classroom so that you're able to learn about this in classes and you're able to see and share these kinds of data and information through virtual portals. We can take our Eagle model, for example, and actually make it available so that other people can 3D print and learn about this in their classes. So it becomes a real mechanism for sharing and distributing data and information in real democratic and altruistic kinds of ways. We can teach these technologies to other research institutions, to other school kids from a younger age all the way up through college classes. So a lot of these 3D technologies are having big impacts on education as well.